In this lecture video, we're going to discuss resonance in AC circuits. And we're actually going to discuss this in the context of radios. So a radio frequency of any frequency produces current of the same frequency. So we're relating the frequency that you're actually tuning your radio to the same frequency inside of the instantaneous current equals max current cosine omega t equation. However, we're going to find that certain frequencies produce a current that is very large. And you've already sort of explored this concept where certain frequencies produce more current versus other when we talked about high pass and low pass filters, when we talked about capacitors and inductors in AC circuits. But now we're going to talk about this for the circuit as a whole. So we have our Ohm's law equivalent for our circuit, where the voltage is equal to the current times the impedance, where the impedance is sort of like your equivalent resistance for the circuit. And we want to be able to maximize the current. So I'm going to solve this for the current. Current is going to equal the voltage divided by the impedance. So in order to get the largest current, we need to minimize the impedance. So let's look at our impedance equation. Our impedance equation equals the square root of the resistance squared plus the inductive reactance minus the capacitive reactance squared. And if we were in class, I'd let you sit here and think about it a little bit, but we're just going to jump right to it. So we can't do anything about the resistance other than making the resistor smaller. But what we can do is set it up so that these two values are equal to each other, so when they're subtracted, you're left with just the resistance. And that essentially is the best way to minimize what the impedance is going to be, because essentially you're knocking out the second term here. So we're going to say that the impedance is its lowest value, we're minimizing it, when the inductive reactance equals the capacitive reactance, or when the impedance is equal to the resistance. Using these conditions, we're going to calculate what the resonance frequency is be. So what frequency do you need to actually tune your radio to in order to get the greatest current? We're going to set the inductive reactance equal to the capacitive reactance and then sub in. And I'm using a little circle to indicate that this is the resonance frequency. And then we're going to solve for the resonance frequency, and this gives us a relationship that looks familiar. And one of the reasons why I stress that you need to make sure that you're not interchanging DC equations with AC equations, because this exact same looking equation appears when we're talking about LC circuits earlier in the prior chapter, but it comes from a different derivation and is used in a different manner. So please make sure that you're sticking to AC equations for AC and DC equations for DC, even if they look like they have the same shape. Now this is useful because we're going to find out in the next chapter that radio waves and electromagnetic waves are going to be very related to each other. So essentially when you're tuning your radio, you're tuning it to the resonance frequency, or a resonance frequency, that produces the strongest current inside of your radio. And yes, it's a lot more complicated than that if you actually design a radio. And that allows you to actually pick up a strong signal, and you can actually allow the radio to do what the radio needs to do. And the way this used to be done, and if we were in class, I actually have a demo, which unfortunately I did not bring home because I didn't realize I would never get to go back to my office, that where we have a capacitor that you can actually change the capacitance of. And so it acts like the tuner in the radio, where you change the capacitance of the capacitor. So you can imagine making the plates of a parallel plate capacitor closer or further together. And this changes what the resonance frequency is, so you can actually tune in and pick up a radio station that way. So this is how you're actually used to tune a radio. Now it's a little bit different, where you would vary the capacitance in order to be able to pick up get the radio set to the resonant frequency to actually pick up a station.